In this video, I will be discussing on types of addressing we need in TCP/IP model for data communication. Okay, so these are the four different types of addresses which we need to understand. So first one, physical address. Physical address is also known as MAC address, Ethernet address, or we can call it as link address, machine address, and so on. So logical address. This address is also known as internet address or IP address. And we should know something on what is port address and lastly specific address. So we will see one by one. So this is what the TCP/IP model, where you can see 5 layers, that is physical, data link, network, transport, and application. So here I am just showing where exactly these addresses are available in OSI model. So specific address is meant for user understandable address. So it is available in the application layer. Port address we need to check in the transport layer. Logical address or internet address we need to check in the network layer, and the physical address will support in the data link layer. Okay. First, let us see what is physical address. So as I already told you, physical address is also known as machine address, or we can call it as a MAC address, link address, okay, Ethernet address. So we have different names. So now let us see some concept on physical address. As I told you, it is the address of a node as defined by its LAN or WAN. Okay, that is true. It is included in the frame. When I told already that physical address is checked in the data link layer. So normally in the data link layer, the data will be in the form of frames. So for every frame, this MAC layer is, that is what machine address is added. And this is the lowest level of address. So at the receiver side, the first layer that address we are checking is MAC address. It's in the data link layer. Then we will check in the IP address in the network layer. Then we will check port address in the transport layer. Then lastly, we will go to specific address in the application layer. So we will call it as lowest level address. So as I already told you that it is also known as Ethernet address. Since Ethernet will use this. So the size of the MAC address is 6 bytes, or we can call it as a 48 bits. So this MAC address is embedded in the NIC card of the motherboard, that is network interface card, during the manufacturing of the system. So these MAC addresses or machine addresses is given by the IEEE, Institute of Electrical and Electronics Engineering. They are the authorized person to provide these MAC addresses to the manufacturing companies. So as I told you, please note down the MAC address size is 48 bits. How to represent this MAC address? So here I have written clearly. So the 48 bit is nothing but a 6 bytes. So we are using what you call that a 6 blocks. Here you can see this is one of the MAC address where you can see 6 block. You can see the column. So this is one block. 07 is one block. 01 is another block. Like that we have 1, 2, 3, 4, 5, 6. We are representing in 6 bytes. And each physical address is written as 12 hexadecimal digits here. If you count 1, 2, 3, 4 like that, total there will be 12 hexadecimal digits. If you take 07, this is one block as I told. So each one is one hexadecimal. Each one can be represented using 4 bits. So maximum number we can have is 2 power 4, means 16. So the values we can have is from 0 to 15, means 0 to F. So any value or any hexadecimal value between 0 to F can be represented in each character or each number. So 07, this is 4 bits, this is 4 bits. Like that each block will contain total 8 bits. So how many blocks we have? 1, 2, 3, 4, 5, 6. So 8 into 6, 48 bits. That's what the size of the block address is. Sorry, MAC address is 48 bits. Hope so it is clear. So if you want to see this MAC address of your system, so what you can do? just go to your terminal or command prompt in your system. Just type CMD. You will get the command prompt. Click on it and then just type IP config space slash capital all or small all, not a problem. Click enter. Then you can see the physical address of your system. Here you can see the physical address is 4C, EB, BD, 0A, 55 and 9C. Okay, hope so it is, you can see clearly that is 6 blocks of addresses. Each block is of 8 bits, 6 into 8, 48 bits. So this is what we call as MAC address. So here it is given the same representation. Yeah, this is what. Among these 48 bits, you can see clearly the first 3 blocks. Okay, 24 bits is mainly used for organizational unique identifier. Remaining 3 blocks, 24 bits is used for network interface controller specific. So it depends upon based upon the network. So this is what the representation of MAC address. Hope so it is clear. So that is what I told you. Just type IP config slash all, capital or small, then automatically you will display the MAC address. Okay. So again, I'm telling this MAC address is checked in the data link layer. So next upper layer we have is network layer, or we can call it as the internet layer. So there we are going to check the IP address, internet protocol address. So some definitions are there. Logical address is necessary for global communication. So we have 2 versions of IP addresses. One is IPv4. Okay, the other one is IPv6. So IPv4 will be of 32 bits. Okay, and IPv6 will be of 128 bits. Please note down this point. No two publicly addressed and visible host on the internet can have the same IP address. What does it mean? So in the global, no two systems will have the same IP address. 100% they should be unique. So this is what we call it as IPv4 representation. So you can see IPv4 will be having 4 blocks. Okay, 4 blocks, and each block will be of 8 bits. Okay, 8, 8, 8, 8. 8 into 4, 32 bits. Hope it is clear. So what is the range we can give in each block? That is 2 power 8. 2 power 8 is how much? 256. So the range is from 0 to 255. So any value between 0 to 55, 0 to 255 will be in this block. So this is one of the valid IP addresses. You can see no 172. Here you can write 172. Each block is separated by dot. Dot 16 is a valid number, 254 is a valid number, and 1 is a valid number. You will not be having any number like 172.16.300.1. 300 will never be, because as I told, each block size will be of 8 bits. So maximum range is for 2 power 8, 256. So the range is from 0 to 255. So the same, this is what hexadecimal representation, dotted decimal notation. If you want to represent in binary, so the same thing can be converted like this. As we know, each block is of 8 bits now. Just convert this 172 into binary using 8 bits. So this is what 10101100. Similarly 16 00010. So similarly 254 and 1. So this is 1. So in this way also we can represent. 2 ways of representing. One is dotted decimal notation. The other one is binary notation. So hope so it is clear. So as I already told you, one more version we have, that is IPv6. So IPv6 will be of 128 bits. So totally there will be 8 blocks here. 8 blocks, that is 1, 2, 3, 4, 5, 6, 7, 8. 8 blocks. Each block will be of 16 bits. So 16 into 8, 128. Hope it is clear. So each block will be of 16 bits. So in 16 bits, we will be each block will contain 4 hexadecimal values. So each character we can represent using 4 bits. So 2 power 4 is 16. The range is from 0 to 15. So any value between 0 to 15 means 0 to F can fall here. So 2001 4444 16 bits. So this 0, when I represent a single 0, it is understood that there are 4 zeros. 90386AB8, it is one of the valid IPv6 MAC address. So hope so it is clear. So if you want to check the IP address of your system, again I'm going to the command prompt. I will just clear it. Just you can type, let it be IP config. No need to type any slash or, and then click enter. You can see the IP address, IPv4 address of my system is 192.168.242.238, which is of 32 bits. And this IP address belongs to class C. So there are 4 different types of classes: class A, class B, class C, class D, and also we have class E. This is research oriented. So all these classes we can understand in the upcoming videos. Okay? And this is what IPv6 address you can see here. FE80 double quotes means there are already 4 zeros. So more information about this IPv4 and IPv6 we will study in upcoming videos when I go for IP addressing in depth. Okay? Sorry. So hope so it is clear. So where we have 2 types of addresses, one is IPv4 and another one is IPv6. So please note this IP address is checked in the network layer of OSI model or TCP/IP model. So this is what the command, as I told you, just you type IP config, then you will get the IP address, MAC address, subnet mask, all this we will see in the upcoming videos. Next, we have very important address known as port address. So port address is the address we are checking in the transport layer. So port address is mainly used to identify the protocol for peer-to-peer communication. Okay. In order to make a peer-to-peer communication, like in order to identify a specific protocol between client and server or between 2 systems, so port addresses are needed. For example, if I'm transferring any text, then I need to activate HTTP port. So the port number for HTTP is 80. So both at the sender side and at the receiver side, the port number will be activated. They should be same. If I'm sending any file, so FTP protocol, so I should use the port number as 21. If I'm using TFTP, trivial file transfer protocol, then 23. Or if I'm going for HTTPS, then port number 44, 43. Like that, we have standard port numbers to identify the protocols. So which protocol we are using, specific port numbers we need to use. So these are all standard ports. So if you want to use your own port number, if you are doing any demonstration, some dummy port number, if you want to assign to any client and server, then you can assign any port number based upon the range. So the port address size is 16 bits. So the port numbers available is 2 power 16, that is 65,535. So the range is from 0 to 65,534. So any port number that fall between 0 to 65,534, you can use as a user defined, except the standard port numbers. So what I mean to say here, port addresses are mainly used to identify the protocols, maybe a standard protocol or a user defined protocol for purpose of communication. Here I have given one port number 3000, which is a user defined, and it is a valid port number because that value falls between 0 to 65,534. So this is something about port address. Again, I'm telling this port address is checked in the transport layer. So here you can see a small demonstration. This is what we call as application layer, okay, where you are sending the data. So when it comes to the transport layer, these 2 addresses are added. As I already told you, in the transport layer, the port address is added. That is A and J. These are the 2 port addresses. One is for client, the other one is the server, or one is for sender side port number, and the other one is receiver side port number. A and J. Some services, like this is FTP service and this is HTTP service. Please keep in mind, these should be same at the receiver side also. If I am sending any file here, A, then this should also be file, FTP. If J is like HTTP, I should open the same port here, HTTP. So it should never change. So when it comes to the network layer, so I'm adding the IP address. Here you can see A and P. One is the source IP address, the other one is the destination IP address. Here also, it is not changing. please keep one point in mind. The port addresses and the IP addresses will never change from source to destination during the data transmission. They are fixed. But MAC address here in the data link layer you can see A and J is the port address, A and P are the IP addresses, and H2 will contain the MAC address that can be changed. MAC address will be gone changing from system to system, whereas IP address and the port address will always remain same. Here I've given the port addresses. These are the services like A, B, C, like that. A number of services will be there. If A is FTP service, B is SMTP service. So those number I have taken here some dummy names. A is FTP, B is SMTP to send a mail. Same services are activated here. Similarly, IP address will never change, but MAC address can be changed from system to system. That point you should keep in mind. Okay. So what I mean to say in this is, whenever the data transmission is taking place between sender and receiver, port address and the IP address are always remain constant in the data block, whereas MAC address will be gone changing from system to system. Hope it is clear. And the last one is specific address. Specific addresses are just addresses that are meant for user-friendly, understandable. For example, if I say what is the URL of a or address of a Google, we can easily remember www.google.com. But strictly speaking, the system can't understand this specific address. So this address immediately should be converted into IP address. So the local DNS server or local DNS host will immediately map this uh, domain name into or specific name into IP address. So these are just meant for user understandable or user friendly addresses like Yahoo Mail, that is like so on so xyz.com, like that. So here I can see www.example.com. That example may be any host name like Google or Reva, whatever it may be. So this will be the subdomain, and this is also subdomain. This is the .com is the main domain. So while explaining about the DNS domain name system, I will explain how exactly this uh, domain name will be searched, and then how it will map the IP address. Okay, so this is something about uh, addresses in a TCP/IP model. So again, I'm telling, in the transport layer, we are going to check the port address, which is of 16 bits, and this port address will be fixed from source to destination. It will never change. And in the network layer, we are going to check the IP address. There are two versions of IP addresses. One is IPv4, the other one is IPv6. So the size of an IPv4 is 32 bits, whereas IPv6 is 128 bits. In order to check the IP address or MAC address, just you type ipconfig in the command prompt. And then the data link layer, we are going to check the MAC address, which is of 48 bits, and it is machine address, which is embedded in the NIC card during manufacturing of the system. Hope so it is clear. Thanks for watching and subscribe for more videos. Bye.